Today we are going to learn about mastering Dockerfile for efficient containerization. In this session, you'll gain skills to write effective Dockerfiles, optimizing them for performance, security, and consistency across environments.
Welcome to our video on mastering Dockerfile for efficient containerization. In this session, we're going to delve into the intricacies of Dockerfiles, the scripts that dictate how Docker images are built. You'll learn about optimizing these scripts for better performance, ensuring their security, and maintaining consistency across different environments. By the end of this video, you'll be equipped with the skills to craft Dockerfiles that enhance the reliability and speed of your development workflows, making your containerization process more efficient than ever. Let's start with the basics of Dockerfile syntax. A Dockerfile is essentially a text document that contains all the commands a user could call on the command line to assemble an image. The most fundamental instruction is from, which specifies the base image for building your Docker image. Always choose a minimal base image to reduce size. Next, the run command allows you to execute commands in the shell. It's crucial for installing packages or running scripts during the image build process. Copy and add are often confused. Both are used to copy files from the host to the container, but add supports additional features like automatic extraction of tar files. The workdir instruction sets the working directory for any run, cmd, entrypoint, copy, and add instructions that follow in the Dockerfile. Lastly, cmd and entrypoint define default commands that run when the container starts. cmd is overridden by command line arguments passed when running the container, while entrypoint is not. Together, they offer flexibility in how your containers execute commands.
Layering is a fundamental concept in Docker, as each instruction in a Dockerfile creates a new layer in the image. To optimize the build, it's crucial to minimize the number of layers. One effective strategy is to combine multiple run commands into a single one, reducing the number of layers and enhancing build speed. This can be done by chaining commands with and. Using a .dockerignore file is another best practice. It works similarly to a .gitignore file and excludes files not needed in the final image, which reduces the build context and speeds up the build process. Leveraging layer caching is critical. Docker caches the results of each step in your Dockerfile, which speeds up subsequent builds. To take full advantage of this, order your instructions from least likely to change to most likely. This way, you maximize the cache usage. Lastly, carefully consider the order of instructions. For instance, placing instructions that are less likely to change early in the Dockerfile helps Docker reuse cached layers, optimizing build times.
Multi-stage builds are an advanced feature in Docker that can significantly reduce image sizes. The concept involves using multiple from statements in your Dockerfile to create different build stages. Each stage can use a different base image, and you can selectively copy artifacts from one stage to another. This approach allows you to include only what's necessary in the final image. For example, you might compile your application in a build stage with all the necessary build tools and dependencies, then copy only the resulting binaries into a smaller runtime image. This results in a much smaller final image, which is particularly important for production environments where image size can impact deployment speed and resource usage. Multi-stage builds are also useful for separating build dependencies from runtime dependencies, further optimizing your images for production. By strategically using multi-stage builds, you can ensure that your Docker images are as lean and efficient as possible. Environment variables are a powerful feature in Dockerfiles, but they must be managed securely. One of the key principles is to avoid hard-coding sensitive data like passwords or API keys directly into your Dockerfile. Instead, use the arg instruction for build time variables and env for runtime variables. This allows you to pass sensitive data at build or runtime without exposing it in the Dockerfile. For handling secrets, consider using Docker Secrets or a third-party tool like HashiCorp Vault or AWS Secrets Manager, which are designed for secure secret management. It's crucial to configure different environments such as development, testing, and production to use distinct environment variables. This ensures that your containers behave consistently across different stages of your deployment pipeline. Always follow best practices for security by regularly reviewing your Docker files and environment configurations for potential vulnerabilities. Secure management of environment variables is essential for maintaining the integrity and confidentiality of your applications.
The Docker build cache is one of the most powerful tools for optimizing build times. Docker caches the results of each step in your Dockerfile, enabling it to reuse these results in future builds if the instructions haven't changed. To effectively reuse the cache, carefully consider the order of instructions in your Dockerfile. By placing less frequently changing instructions at the top, you maximize cache reuse. However, sometimes you need to invalidate the cache to ensure that fresh data is used, such as when pulling a new version of a base image. One strategy is to use arg instructions for versioning, which can force cache invalidation when necessary. Optimizing the build cache can significantly reduce build times, making your development and deployment processes much more efficient. Remember, the key to caching is understanding when to leverage it and when to bypass it for updated dependencies or configurations.
The .dockerignore file is an essential tool for optimizing Docker builds by excluding files and directories from the build context. This is particularly important because Docker sends the entire context to the Docker daemon, and a large context can significantly slow down the build process. By specifying patterns in your .dockerignore file, you can exclude unnecessary files and directories, such as local development files, build artifacts, or version control metadata, from being sent to the daemon. This reduces the size of the context and speeds up the build. Effective use of .dockerignore not only improves build performance but also enhances security by ensuring sensitive files are not included in the build context. When crafting your .dockerignore file, use patterns similar to those in a .gitignore file, and regularly review it to ensure it aligns with the current structure of your project. This practice is crucial for maintaining efficient and secure Docker builds. Debugging Dockerfile issues can be challenging, but understanding common errors and effective troubleshooting methods can simplify the process. Common errors include syntax mistakes, incorrect path references, or failing commands and run instructions. Start debugging by examining Docker logs, which provide detailed information about the build process and any errors encountered. Use the Docker logs command to view logs for a running container, helping you identify runtime issues. For a more structured approach, consider troubleshooting each Dockerfile instruction step by step. You can build and test sections of your Dockerfile individually to isolate problems. Container inspection techniques, such as using Docker inspect or Docker exec, allow you to explore the state of a container and execute commands inside it for further diagnosis. Additionally, tools like Dive or Hadalint can assist with debugging and optimizing your Dockerfile. With the right approach and tools, you can efficiently resolve Dockerfile issues and ensure smooth builds.
Security is a critical consideration when writing Dockerfiles, as vulnerabilities in your images can expose your applications to threats. Adhering to the principle of least privilege is fundamental. Avoid running containers as the root user, and instead, create a user with only the necessary permissions. Regularly updating your base images is essential to incorporate security patches and updates. Use tools like Docker's security scanning feature to identify and mitigate vulnerabilities in your images. It's also advisable to use trusted base images from official repositories or verified publishers, as these are more likely to be maintained and secure. By implementing these security best practices in your Dockerfiles, you can significantly reduce the risk of security incidents and protect your applications from potential threats. In conclusion, mastering Dockerfiles is a crucial skill for efficient containerization. By optimizing your Dockerfiles through best practices such as effective layering, secure environment variable management, and leveraging multi-stage builds, you can create Docker images that are both performant and secure. Remember, consistent application of these practices ensures that your containerized environments remain reliable and efficient across different stages of development and deployment. We encourage you to continue exploring Docker's advanced features and tools to further enhance your containerization skills. Thank you for joining us in this journey towards mastering Dockerfile for efficient containerization.